46. Well, thank you for attending this session. It's called Continua Implementing FHIR, and if you don't know some of the terminology, that's one of the hopes that I've tried to put forward for you today. About myself, disclaimer, I am not a developer. I'm an engineer, I'm a biomedical engineer. I work at University Health Network. The developer counterpart at our group is James Agnew. So he deals with a lot of the FHIR implementation, and I hope you've attended some of his Happy FHIR talks. I am a biomedical engineer who has been involved in IEEE, Bluetooth, as well as Continua Health Alliance. So I deal with a lot of the medical device data and formatting, and bridging the gap between the device data and FHIR and other API and applications. So in my daytime job, I work with an amazing group of developers, and we develop chronic disease management app. About 15 years ago, we wanted to connect a glucose meter to our diabetes app. And then we saw the array of diabetes devices out there. And we were going nuts. As a hardware engineer and trying to read every single proprietary protocol for each individual glucose meter was nuts. We spent a lot of time developing, and then we hear, once we're ready with our application, that the device changed. Something in the protocol has changed, and we would have to go back to our code and develop it again. So this is really our driving factor, because we want to present to patients the opportunity to choose any device to use at home with our application. And our applications have expanded to include other chronic disease management like heart failure and COPD and others, so that we can connect devices at home to our application and then send it over to other services and our hospital system. So the objectives today, and I hope you guys are in the right room, today I will be talking a little bit about PCH Alliance, which is a nonprofit organization that I'm part of. Device standards, yes, there are more standards outside of FHIR. And then Continua design guidelines and how they all match. We're at FHIR DevDays. Why do we care about devices? Because device data is important for both at home and in hospitals and to clinicians for patient care. So how do we use the device data upload using FHIR observations and resources? And then I'm going to go into a specific use case around using medical devices for a pregnancy disorder called preeclampsia. So Personal Connected Health Alliance is a nonprofit organization that looks specifically at personal connected health. They want to improve efficiencies and cost in healthcare in general. A lot of the expenses is in the traditional hospital care setting. So if we could move towards more of a home healthcare and look at preventative and wellness scenarios, then we could potentially decrease the amount of money that is required for healthcare. We want to promote individual ownership of the data and also use personal health data to share with others. A lot of times patients have caregivers, relatives that want to understand and know how things are going with a patient. As well as social network. You see a lot of times people being part of a wellness group and trying to motivate each other through their use of data. And then it's a communication tool, as we heard yesterday in the keynote speaker presentation. All of this data and APIs and device communication and so forth is all about communicating with each other and trying to figure out how to treat, how to diagnose, how to prevent, etc. And then we want to create new incentives towards personal responsibility and innovation. And back to my personal group in Toronto, we want to actually develop innovative applications so patients can manage their health. So Personal Connected Health Alliance is really two parts. It was founded by the HIMSS organization, and you may have previously known the mHealth Summit. It's now called Connected Health Conference. This was actually held in October, a couple of weeks ago. And so it's a yearly event where researchers, industry partners, all healthcare providers all come together to learn about what is new in mobile health, consumer health application, and personal health data. And then I'm not going to talk too much about the Connected Health Conference and go into the Continua design guidelines. That's the second facet of the Personal Connected Health Alliance. It is the publishing and promotion of technical guidelines and implementation for interoperability. You might have heard the term plug and play and things like that. So Continua design guidelines are a way to look at interoperability and the ecosystem of devices and healthcare. So this is just an overview of what we're talking about in terms of Continua scope. We've got on the right-hand side of the screen here the home healthcare situation where you may have a patient with a medical device at home. They have a gateway, a cell phone, a PC, something capturing that information, and then through the internet, of course, connecting that with healthcare providers, caregivers, and potentially their personal health records. Let's start going into a little bit more specifics here. This is a similar diagram, however, we are representing here three interfaces that we're looking at as a Continua. We've got on the right-hand side, again, personal health devices, the medical device that a patient might use, personal health gateway, that's where we're actually capturing and collecting all that data from the home, and then aggregating them using current standards there towards health and fitness services, let's say a remote patient monitoring or a telehealth service, and then potentially going into the healthcare information systems, which is what we're calling the HIS interface. So all of these interfaces, these three interfaces, are represented by several different organizations and standards organizations that deal with each individual part. So my counter track leader, Todd Cooper, is from the IHE in HL7, and they deal primarily in the services and the HIS interface. I'm going to talk a lot more about the personal health devices side of things, and also the services. So as a background, there is a lot of guidelines, and the Continua Design Guideline is actually a collection of documents that is actually presented here. These are all freely available documents that you could look up. It is promoted by the ITU, which is a United Nations International Telecom Union, I think, is the actual acronym. And so these documents here actually specify the technical guidelines. And I'm going to go through a bit of H810 and H812 and a little H811. So I'll be covering 810, 811, and 812 in a broad overview for today. Again, this slide is just telling you that it is open and it's developed in 6 languages. So if English is not your primary language, please feel free to see if your language is covered there. And of course, the PCH Alliance has a lot of information on their website. All these slides are going to be provided to you as well. I've included links in the Zula channel for medical device track, so feel free to take a look at those. Finally, when we talk about plug and play and actually finding devices that work, what Continua wants to ensure is that people understand that they can go to their pharmacy and pick up a device and it will just work at home with their gateway. And to ensure that, they go through a very rigorous certification process. I'm not going to go into what is entitled in the certification, but basically it's a conformance testing that manufacturers of personal health devices and gateways and other systems go through so that they ensure that when a patient picks up a specific device with the Continua logo on it, it will work, okay? And so the testing suite allows you to, and the testing process allows you to guarantee that these are plug-and-play ready. PCHA Alliance, or PCH Alliance, is not alone. It is working with a lot of different organizations to make this interoperability ecosystem work. And these are some of the key alliances here. Like I mentioned, IAG, HL7, HL7 FHIR, Bluetooth, SIG, and IEEE. Since we're in Denmark, what I have here is the who cares about, Continua, PCH Alliance, and all these interoperability challenges. This is updated as of 2017. Some of the areas that are focused on adopting Continua guidelines, because people like my group in Toronto are fed up with not having the choices and having to rework and re-engineer and redesign everything every single time a new application or a new device comes on board. Okay, so the data exchange landscape, again, similar to that overview, but now I'm going to go in specifically to the standards that support personal health devices, or what we're calling the PHD interface. So this is between a medical device and a gateway system. Continua does not develop a standard. Continua is not a standards organization or an SDO. What it does is it leverages existing standards that are in the marketplace, and it wraps around certain implementation guidelines, and it adds things that may not fall under the categories of the individual standards. So we're talking about adding guidance around security, for example, so that you have reliability and secure transmission between the different interfaces. So the two main device standards that Continua supports is the IEEE 11073 standard and the Bluetooth low energy standards or specifications. IEEE is the Institute of Electrical and Electronics Engineering. IEEE is an application layer protocol that specializes in the specific one that I'm talking about, the 11073, specifies the medical devices. And I'm going to go into how they do this and how they model the data that actually exists within a medical device. And it focuses on interoperability and it's transport agnostic. So IEEE can run on USB transport, so a serial interface, Zigbee, or Bluetooth traditional interface. So the way that it's modeled is that we have specific terminology for devices. They're called agents, and it communicates to a higher CPU processing, higher battery power device, which is called a manager. And they do this and exchange communication through a specific communication protocol. That is the 11073 and 20601 document. And they model the information through what is called the domain information model. And what that is an object-oriented model that describes not just the physiological data and the measurements that are captured in a medical device, but things like the actual medical device information. And so this type of, these types of information are captured and grouped into separate objects. And each object may have certain attributes. So for example, I will show you a use case for the blood pressure. The blood pressure is the agent, it's the medical device. It has an object called an MDS, or medical device system, which describes everything about the device itself, its product specs, its software version, its manufacturer, its regulatory, all those things. It could have an object that captures the blood pressure. It is a blood pressure monitor, so it's blood pressure data. And that object could have attributes such as a systolic, diastolic, and mean blood pressure. As an attribute that it has units of measurements, which is millimeters of mercury, and so forth. And then it could have other objects as well. And so that is the basis of what a domain information model from a device level looks like. And so I just talked to you again. MDS is a device about the device itself. A metric object could describe what this numerical measurement is. I'm not going to talk about scanner or PM store objects, but basically scanner is the ability for a manager to actually query and look at the different events that have happened, and then the PM store is synonymous to, let's say, historical data. And so again, this is what a typical domain information model looks like from IEEE. And those are the attributes of a numeric object for blood pressure. So blood pressure monitors are only one of many devices that the IEEE support. So we've got pulse ox, thermometers, weighing scales, glucose meters, insulin pumps, CGM, and all of these devices, again, have a specific domain information model, modeled with different objects, which have different attributes to them. And again, these are the completed standards. So there's a wide variety of devices out there that could be standardized to the 11073 suite. And these are some of the projects under it. And this is just to describe that it's a standard that is promoted by the FDA when a medical device is being regulated. So medical devices, as opposed to some applications, are regulated and classified under FDA and other regulatory bodies like the EU, or EC, sorry. And so FDA does recognize these IEEE standards. So I said there were two standards organizations that Continua supports. So this is Bluetooth Special Interest Group. So this is a group that does all Bluetooth things, okay? So you guys all probably have a phone with Bluetooth, a car, a radio, a speaker, you know, a mouse clicker. All of this is under the Bluetooth organization. There is a special working group that dedicates itself to medical devices, and it's called Medical Device Working Group. So part of the Bluetooth Medical Device Working Group, they concentrate on medical devices that have Bluetooth abilities, okay? And really Bluetooth allows medical devices to send wirelessly their information. And this is different from the IEEE, as it also has profiles and specializations that it has a format to the data that they exchange. There's two types of specifications that Bluetooth needs for medical devices. There's a core specification. Basic, how do I pair with another device? How do I connect to it? And that's called the core specification. But when we're actually talking about specifying medical device data, you look at things that is called the generic attribute specifications. And you will have a generic attribute specification for a blood pressure monitor. You'd have a separate generic GAP specification for a pulse ox, for a CGM, etc. And so these ones are the medical device GAP specifications that are currently either completed, in revision, or in development. And again, very similar to the domain information model in IEEE devices, what you have is a hierarchy. You've got a profile that tells you about the device. You've got services, what it can do, its capabilities, and then characteristics is similar to what I described as attributes. The actual numerical data values, for example, for an observation or a measurement. So again, just a different way to model it based on how the data is being transmitted across wireless interface. This is just a summary of how IEEE devices and Bluetooth smart or low energy devices interact with each other, and also how it will eventually interact with the HL7 ecosystem or services interface. This is, again, all those supported in terms of the applications and devices. And again, it's a little hard to read here, but slides will be presented and provided to you. Okay, let's actually get into FHIR and start talking about why Continua and device data is important to the FHIR community. What we want to do is, there's a lot of information that is important to physicians and to, again, care providers and services that allow us to monitor patients at home. And so what we want to do is ensure that there is no loss of information, okay? We want to make sure that whatever is captured from the device, even the timestamp, for example, is accurate all the way down to when the doctor sees it on their EMR or another application. So we also have been working with IHE for a long time in what's called PCD01. So it's another way, another formatting. I think it's version 2 messaging, HL7 version 2 messaging. And it's been in existence for a long time. But as FHIR has been kind of growing and being more adopted by a lot of companies and applications, what we wanted to do is stay within the times and also define how we want to represent the medical device data in FHIR observations. So, if we move, we were over there, the personal health devices, we briefly talked about the data that can come out of the medical devices. What we want to look at now is the services interface. And Continua does look at HL7 FHIR SDU3, and then at the health information services, you can then upstream that information to healthcare informatics, the HIS interface. Okay, so I stole these slides from Todd from yesterday's presentation. Again, going back to the 11073 model, you've got a top-level medical device information, or the MDS. You've got potentially virtual medical devices, subsystems, channels. He was talking a lot of these about for POCD, or point-of-care devices, which are found in healthcare. So ventilators, physiological monitors, a ton of data. Now we're talking, and this is how it's mapped to FHIR resources. But personal health devices at home are a lot less, I guess, less intricate as those that are found in the hospital environment. And so what we're looking at is really the medical device system data, metrics, and the patient. So we really only use 3 resources: the patient resource, the observation resource, and the device component resource. And I'm going to go into those 3 in a little bit more specific. So the 3 FHIR-defined resources are those 3 mentioned here. And what we do is bundle those resources together, so that when we transmit a medical device data element, what we're getting is a connection between who it is for, what device did it come from, and what are the actual observations values. Okay, and we use these in different ways. And the Continua guidelines goes through each of these resources and step by step looks at how we want to define the different codable concepts. So for example, patient resource. What we have is, we want to manage the patient identity. A lot of these devices do not have a mechanism to actually identify the patient themselves. And so there is a lot of work that needs to be done to say, yes, someone has taken a blood pressure, yes, someone has taken a glucose meter, and this is who that person is, and making that connection. And so in the guidelines, what they specify with patient identity is that you need to provide a logical ID for them in the FHIR resource. How do we do that? Well, there's a few ways. Either someone specifies from a service saying that, yes, this patient is given this value, and the gateway, the application at home, is going to input that logical ID or knows about that logical ID and is provided that. Therefore, all the information that comes from the medical device is appended with that logical ID at the gateway, and then it's sent out to a FHIR resource. So that's the simplest case. Again, if a service or an application tells the gateway at home who this person is, and we can easily append that into our patient resource and observation. If that is unknown, okay, if they don't provide a logical ID, there's a couple of ways that you can identify the patient. Okay, one of those things is what we call patient designators. Okay, patient designators are when we don't have the ability to have a logical ID given to a medical device or a medical device with a personal health gateway. This could be a serial number, so it could be a tracking mechanism that says, okay, we've sent this patient with this medical device, and we know this medical device has a unique identifier, and it's the serial number. We can do that, and then the health and fitness service or the application downstream can append that logical ID to the medical device data. The other point is that a gateway could request, say, I have some information that I have from the medical device. Tell me who it is that is assigned to that, and give me that information, and then I will get that, and I will append that logical ID before I send any observation. So there's a few challenges because, of course, not all medical devices have the ability to identify the patient. Okay? So those are some examples of how we could actually use the patient resource and have the observation linked to the patient. The second resource that I talked about was the device component resource. Again, there is so much rich information from the IEEE and from the Bluetooth specs about the device itself. Again, what software version, what the product specs look like, time attributes, all of these things are not actually the measurements from a patient. And so we use the device component resource in a personal health device situation. Again, you have a system ID. What is the device? It is a blood pressure monitor or a pulse oximeter, product specs, etc. So you need to have a system ID or a logical ID again for this resource. And what Continua specifies is that it should be an IEEE system ID. The third and I guess the most interesting resource that a medical device uses is the observation resource. To ensure end-to-end interoperability and to ensure that the data arrives to the clinician or to those that are downstream, what we want to do is make sure that the nomenclature is semantically correct throughout the entire ecosystem. How we do that is the devices themselves have a huge list of semantics and nomenclature codes for every single measurement, for every single type of attribute a medical device has. And so we use these MDC codes from a nomenclature repository, and we actually insert that into the codable concept under the code section. So when you're coding, let's say, a observation, you're going to have a code that specifies that it's a non-invasive diastolic value. That value in IEEE has a numerical value, and we're going to insert that into the code section there. And again, that is the way that Continua is going to guarantee that when a doctor perceives that diastolic or systolic measurement, they know exactly the definition of that value. It is, truly a systolic from a non-invasive blood pressure monitor. And again, this is the representation. Another, interesting thing is that, yes, we specify that we need to use the IEEE codes. FHIR does specify that we need to use LOINC codes. So what we are doing is that you always have to have the pair, okay? You always have to have the IEEE followed by the LOINC nomenclature. And finally, what can we do with this? Why do we care? Again, devices are critical to patient management and different use cases. I'm just going to go and explain one of the many use cases that devices are used at home. Again, you can use it for diabetes care, heart failure, hypertension, COPD, and other health and fitness examples. And by using FHIR and all these other standards that Continua supports, what we ensure is all the data can be transferred and interoperable with each other. So let's look at the use case. Annie is a 31-year-old female and has first pregnancy. So we're in an OBGYN type of scenario. Asymptomatic hypertension, what does that mean? You've got certain measurements that in blood pressure that are extremely high for that patient. And proteinuria, which is a measurement, a lab measurement of how much protein is in your urine. She delivered a 7 pounds, 5 ounce baby boy, and the baby was delivered without complication. Initially, Annie was going for prenatal visits. They were checking her every week after 35 weeks, and what they found out was that she was achieving high protein in her urine. Follow-up lab results also confirmed that there was high urine concentration, and so she was told to record her blood pressure every 6 hours after that. So the combination of high blood pressure and high protein in the urine is what's called preeclampsia. Preeclampsia is very fatal. Some of the downsides is that you could potentially have a seizure, jeopardizing both mom and baby in that sense. So it's very important to take home this blood pressure monitor and actually record this. And of course, your clinic needs to understand this. So this is one use case that says, my doctor needs to know this information, but the patient cannot stay at the clinic to record their blood pressure every 6 hours. So Annie's blood pressure spiked. What can you do with that? An application could potentially take this information and alert a physician, right? So if you imagine what you can do with this data, it actually doesn't alert the physician. It sends an SMS text. So it's achieved above threshold hold a blood pressure value. So it reminds Annie at the personal gateway or on an iPhone application, you should actually check your blood pressure, not 6 hours, every 6 hours, but now every 3 hours, etc. So this is one case where you're using that data to notify Annie to increase her blood pressure monitor. Following these readings, for every 4 hours, there's a bit of discrepancy, so I'll make those changes before I post these. And then she keeps on doing that. Over the next 48 hours, continues to trend up. CDS also says, look, you're not doing very well, your blood pressure hasn't stabilized or gone down, come back and come into the hospital. And so she goes into the hospital. One of the things that we want to do in the interoperability ecosystem is combine the blood pressure data at home with the blood pressure that she might receive when she goes into the hospital and is admitted from a physiological monitor. So 2 different devices, one in the hospital and one at home, but they are still blood pressure. And so she gets monitoring, she gets medication, the providers are able to see her home monitoring data, they're able to monitor her at the hospital, and they're able to treat her. So that is a basic type of use case that can be used for both home monitoring and hospital monitoring. And again, the data, because it's interoperable and it's because we understand how that data is coming from the home and the hospital, we can combine that to make a clinical decision. So again, non-invasive blood pressure, I have one here that you can see, systolic, diastolic, mean arterial pressure. You could have a pulse rate. This is used at home. You can bundle this information. Again, we're using 3 resources: patient, device, component, and observations. Observations. And these are the values that you can use. The patient resource, the JSON file, could look like this. Again, we've got a patient ID. I haven't gone through how that logical ID is transferred here, but assuming that the logical ID is returned to the personal health gateway, this is a sample message of that. And then the device component, again, all that information that's embedded within the device. And then, of course, this is a specific profile, so we're using the Continua Health Alliance profile to actually report this information. And then the observation itself. Okay, so again, we've got the IEEE encoding there, followed by the LOINC that specify that this is a blood pressure measurement or vital sign. This is the codes that are read from that nomenclature data set, and how we actually change that code or encode that. And then, of course, using a component to actually code the diastolic, systolic, and mean grouped together. And that's about it. I guess the takeaway that we want to say for Continua Health Alliance is that we can choose any Continua device, certified device, and connect it to any Continua certified gateway, and they will all have this type of profiling when you receive it in a application or a service. Okay, so for a patient, from a patient's perspective, this allows for ability to choose any of those devices. For those who are developing application, you don't have to look at every engineering proprietary protocol. You can use, the standardized way. And then for those who are using it for services, you're receiving the FHIR message exactly the same way for any Continua certified device. And that is how we try to achieve end-to-end interoperability through these guidelines. So I hope that gives you an overview about the different standards. I've got devices to play with on the device table. I've got a gateway that's connected to the FHIR test server, so you can see real live messages come through. The gateway itself, I think, is freely open and available if you want to go home and try it out yourself with different Continua devices and take a look at some of the JSON messages in detail. And so happy to answer any questions at the device table. That's it. Thank you for attending.